Hello everyone. Today we are going to discuss about this Azure Service Bus, which is for enterprise messaging and integration. So in this video, we are going to understand the architecture, the security and best practices, which is related to Azure Service Bus. So, so first of all, we have to understand what is Azure Service Bus, right? So this is a fully managed enterprise message broker, right? That enables reliable asynchronous communication between distributed application and services, which means that if you have got multiple microservices and so and if you want them to communicate with each other, so you can use this Azure Service Bus. So Azure Service Bus is one of the message broker, just like RabbitMQ and Kafka, right? So which helps us in building this loosely coupled applications, right, which interacts through messaging, right? So it supports queues and topics with subscriptions, making it suitable for complex enterprise workflows. So since it is fully managed, developers do not need to manage infrastructure or scaling. It is commonly used in microservices and integrate this integration heavy architecture. Yeah, so here is a typical architecture. Uh, that's what it looks like. You have got message producers, and you've got some message consumers, and you've got the Azure Service Bus that is facilitating the message transfer through either queues and topics, right, to different Azure services. So why Azure Service Bus is important? So this Azure Service Bus improves system reliability, scalability, and fault isolation by enabling asynchronous loosely coupled communication, and that's where is important. So because in distributed applications, what happens is like if you make like sometimes direct synchronous calls can lead to cascading failures, and so because it is so tightly coupled, and if one a service fails, the other service will eventually also fail. So service bus allows producer and consumer to operate independently, ensures messages are not lost during spikes or outages. So this makes it critical for mission critical enterprise workloads. So all the messages that is sent or produced by the producer are not lost, and somehow they are stored in this Azure Service Bus. So if you look at the high level architecture, so this Azure Service Bus acts as an intermediary layer, as I just showed you in the earlier presentation, between message producers and consumers. So handling messages storage, delivery, and routing. And this producer send messages to a queue or topic, hosted in a service bus namespace, and these consumers receive messages asynchronously based on the availability. So this platform manages persistence, retrieves, and delivery guarantees. This architecture supports both point-to-point and publish-subscribe pattern. So if you use queues, then it's a point-to-point, point-to-point pattern. But if you use topics, then it's a publish-subscribe pattern. So what is service bus namespace? So this namespace is a logical container, basically, for all service bus resources that we discussed, like queues, topics, and subscriptions. So this namespace provides a scoping boundary for access control and configuration. And this is usually associated with pricing types like basic, standard, and premium, right? And this network rules and authentication settings are applied at the namespace level. Like proper namespace design is important for isolation and governance. And so one of the thing which is of which part of this Azure Service Bus, which I said is used for point-to-point communication, is a queue, right? So this queue this message that is produced by one of the service is consumed by a single receiver, and any message that is emitted here in point to point is only meant for the dedicated consumer. So these queues are useful when exactly one consumer could should process a message. So messages are stored durably until they are successfully processed by this consumer. uh, yeah, but let's say in case you have got the same service which is with the different multiple instances. So in that case, if one of the service receives the message, right, then it will be removed from the queue itself. So it ensures that any message, if it is processed once, it is cleared from the queue. So in the topics and subscriptions, so this topics enables us to use this publish subscribe messaging, where multiple subscriptions receive copies of a message based on filter. But if you remember in queue, it's just only one message. But whereas in topics, it's each consumer is going to get uh, its own copy. So a producer sends a message to a topic, and so multiple subscribers can receive the same message, independently. So this filters allow selective message delivery based on properties. This is useful for event-driven and event-driven scenarios. Okay, so moving on to internal message flow. So basically, messages are sent, persisted I mean stored, and locked for processing, then completed, abandoned, and deleted. So, okay, yeah. So when a consumer receives a message, service bus locks it to prevent parallel processing, right? So the consumer must explicitly complete the message after successful processing. So if processing fails, the message can be retried or moved to the dead letter queue. So this ensures a reliable delivery, right? So dead letter queue is where your messages are saved, of course, then which is then later processed to be sent to the, retried basically. So moving on to the next, so key concepts and terminology. So here, so in the important concepts include like message logs. You need to understand this message logs, sessions, delivery count, TTL, and dead letter queue. So yeah, message log prevents multiple consumers, from processing the same message. And this sessions guarantee ordered processing for related messages. And TTL means like time to leave. So control message expiration. So each message can also have this expiration. And this dead letter queue stores messages that cannot be delivered or processed successfully. So these are some of the things that you need to understand when you are learning about this Azure Service Bus. And message delivery guarantee, right? So Azure Service Bus provides at least once delivery, with support for duplicate detection. So which means that the messages are not lost basically, and uh, may be delivered more than once. So at least once it will be delivered. So duplicate detection helps handle item potent processing. Exactly once processing must be implemented at the application level. Understanding these guarantees is critical for data consistency. Okay, the security model, we need to understand this. Azure Service Bus uses the Azure Active Directory and shared access signature for authentication and authorization. Because this Azure AD provides role-based access controls for enterprise-grade security. This shared access policies offer token-based access for applications. So permissions can be scoped to send, listen, or manage, right? So network security can be enhanced using this private endpoint. So you need to understand the security model as well, because the considering the security point of view, this enforcing this access control is important when using this enterprise messaging. Okay, so reliability and fault tolerance. So here, service bus ensures durability and resilience from message persistence and retrieve mechanism. So message basically how it is ensuring that the messages are durable. So messages are stored durably, across failure. Automatic retrieves handle transient issues. So dead letter queues prevents poison messages from blocking processing, right? So these features make service bus suitable for critical business workflows. So Azure Service Bus scales through competing consumers, partitioning, and premium messaging units. So multiple message consumers can process messages in parallel from a queue, but anyhow, the service bus ensures that if anyone if any one service processes a message, then it is done. Like the message is removed, and it will not be sent to the. I mean, it will not be available for the other services to be processed. And so moving on to integration with Azure services, like so here the service bus integrates with Azure functions. So you can integrate this Azure service bus with Azure functions, logic apps, event grid, and microservice platform. So let's say if you have created your own microservice, then of course you can use this Azure Service Bus to integrate with your application as well. So Azure functions can trigger automatically on Service Bus messages. So let's say if there is a message that you sent on a Service Bus, so it can also invoke this Azure functions. So this is one of the trigger as well, along with the other triggers that Azure functions have. And so Logic app enables the low-code workflows whenever there is any message from the service bus. And this service bus often complements Event Grid for command-based messaging. It plays a crucial role in enterprise integration work architecture because a service bus basically is for carrying the messages. Event Grid, you can think, as I mentioned earlier in my other video, that it's used for like event notifications, like a small weight or a small payload, I can say, that carry a message with a small payload. So that's where the event grid can be used, and for the payload that with a larger messages, the service bus can be used here. Okay, so here we are going to just compare this Azure service bus with the Azure storage queue. Right? So Azure Service Bus offers richer features and guarantees compared to Azure Storage Queue. So storage queues are simpler and cheaper, but lacks advanced features. So Service Bus supports topics, sessions, transactions, and data lettering. It is better suited for enterprise and complex workflows, whereas you will not have those things in the Azure Storage Queue. Right? So again, it depends on the cost and cost constraints and the requirements. So it's like so Azure Storage Queue is like a cheaper alternative to Azure Service Bus. And if you compare this Azure Service Bus with the Azure Event Grid, so this Service Bus is designed for commands and workflows, while Event Grid focused on event distribution. Event Grid is optimized for high throughput event notification, and whereas this service bus supports durable message processing and complex routing. And this Event Grid does not guarantee message retention like service bus. They are often used together in architecture. Yeah. So moving on to common use cases. So typical use cases include microservice communication, background processing, and system integration. So those system bus, no service bus is commonly used to decouple microservices. It enables reliable background job execution. Uh, Enterprises use it to integrate legacy and modern systems. It is also used for financial and order processing workflows. And so the best practices for the service bus, so which is designed for, I mean, basically designed for this, idempotency, monitor data queues, and choose the correct tire, because there are different tires available. So consumers should safely handle, duplicate messages. So, I mean, one of the best practices to ensure that the consumers that you're creating, they should safely handle these duplicate messages. Uh, right? So dead letter queues must be monitored and processed because uh, the what happens is if the message was not processed, some of those messages are saved in the dead letter queue and because to be tried later. So you must ensure that they are monitored and processed accordingly, and use sessions only when ordering is required. Right? Like use proper sessions, and of course like you also need to ensure the standard and premium triads basically based on your throughput and isolation needs. So what are the few common mistakes, so common mistakes and anti-patterns. So common mistakes include long messaging locks, ignoring retries, using service bus for real-time streaming. So long processing without lock renewal can cause duplicate processing. ignoring retry and deleter handling leads to failures. And the service bus is not designed for high frequency telemetry streaming. So these are a few of the limits to avoid these performance issues with the service bus. So in summary, Azure Service Bus is a reliable enterprise messaging service which is designed for scalable and decoupled system communication. So this service bus enables asynchronous, durable, and secure messaging in one line, if I have to tell you. So which supports queues and publish subscribe patterns, and we, and its advanced features make it suitable for enterprise workflows. Yeah, so this is all about the Azure Service Bus that we have discussed. I hope you understood most of the things in this service bus. And if you have got any questions, just drop in the comments. Happy to help. Thanks for watching, and please don't forget to like and subscribe this video. And thanks for watching.